In this video, you will learn about the reaction stoichiometry, particularly the limiting reactant. Let's look at this chemical equation. It is already balanced. If there's no coefficient in front of it, it is 1. So in this case, it means 1 mole of hydrogen will react with 1 mole of chlorine and will produce with 2 moles of hydrochloric acid. Let's say if I have 1 mole of hydrogen, it will react with 1 mole. That's what this coefficient here means. And it's going to yield 2 moles of hydrochloric acid. What happens if I put additional hydrogen in it? Let's say I put 2 moles of hydrogen in it while keeping the chlorine just 1 mole. What will happen here? Since we don't have enough chlorine to react with the extra or excess amount of hydrogen, look at here, 1 mole and 1 mole. So if 1 mole consumed, what happened? That means even if we have extra amount of hydrogen, we don't have any more of the chlorine left. That means if you have 2 mole of this hydrogen, have 1 mole of chlorine, what happened will be you still will only get 2 moles of hydrochloric acid. And what happened is, and then you have 1 mole of this left, because there's no more chlorine to react with this excess amount of hydrogen. Okay, so what happens if you have 2 moles of hydrogen and 1 mole of chlorine, you are going to get 2 mole of hydrochloric acid and the excess amount of hydrogen. So over here you still have 1 mole of hydrogen over here. Okay, so the one that is going out first, we call that a limiting reactant. So by definition, the limiting reactant is the reactant that is entirely consumed and therefore limiting the amount of product that may be generated. Okay, let's look at an example. Over here, let's look at this. Upon reaction of 1.274 gram of copper sulfate, so here we have 1.274 gram that will react with 0.972 grams of zinc. So over here, zinc, I have 0.972 grams. Okay, when you look at this one, do we know which one is a limiting reactant? Some of you may say, oh my God, this one only has 0.972. It has less. Therefore, it must be the limiting reactant. No, you cannot say that. Why? Because the equation, the coefficient here, it is just for number of moles. It's not about in grams. So we have to convert everything into moles in order to compare. We know the coefficient here is 1 to 1. Okay, so after we convert it into moles, then we can compare, see which one is limiting it. Okay, so how do we convert it into moles? So now, copper sulfate, CuSO4, I know that the molecular weight for this one, it is 159.62 grams per mole. Okay, by now you should be able to do molecular weight or molecular mass or formula mass. Okay, so if I have 1.247 gram, so 1.247 gram, we need to cancel out the gram, so gram should be over here in the bottom, 159.6 per mole. Let's see what we have. 100, okay, so I did my calculation here. It is equal to 0.00798. It is 0.00798 mole. That many moles. Let me write it down here. It is 0.00798 mole. Okay, so let's look at the zinc. The atomic weight for zinc is 65.38. 65.38 grams per mole. Now I have 0.972 grams. So 0.972 gram multiplied by, I want to cancel out the gram, so I put the gram in the bottom, 65.38 per mole. So what I get is 0.0148149. Okay, so that is about 0.0149 mole. Okay, so I'm going to write it down here. So this one is 0.0149 mole. It's about the zinc. Okay, so let's see which one is the limiting reagent now. It should be 1-to-1 ratio, but look at this. Which one will run out first? There should be 1 mole for each mole. Obviously, this part will be the limiting reactant. Okay, so whatever products we have, it will not depend on the zinc anymore. Why? Because we will have an excess amount of zinc. Let's say we just put an infinite amount of zinc in it. It's the same thing, because over here we have much more than what we need. And therefore, the copper sulfate, in this case, it is the limiting reactant. Sometimes it's also called limiting reagent. Okay, so what is the question asked about? How many grams of copper metal we expect to produce? So we are looking for the amount of copper. Okay, first of all, how many moles of copper will we produce? Let's look at the mole ratio. It is 1-to-1 ratio. And therefore, we should expect how many moles of copper? I'm going to change the color. Okay, so for copper, I know it is, since it's 1-to-1 ratio, it will be 0.00798, that many moles. And the atomic mass for copper, it is 63.55. 63.55 gram per mole. So when I multiply these two together, what I will get is, multiplied by 63.55. I get 0.507 gram. Get 0.507 gram. Okay, let me repeat what I just did. The question gave us, instead of moles, it gives us in grams, because the equation, when we balance it, it is the ratio about moles. That means the coefficient only has to do with the number of moles. It's the 1-to-1 ratio. And therefore, we have to convert grams into moles. And in order to do that, we have to divide that by the molecular weight. Okay, so we get the number of moles, and from there, we can determine which one is the limiting reactant. We only look at that number because whichever is excess amount, we don't need to care for that part. In this case, only looking at the limiting reactant, which is 0.00798 moles. From there, I can tell that copper over here, since the coefficient is 1-to-1 ratio, and therefore it should have the same number of moles as the copper sulfate over here. So I determine how many moles I have, and then multiply that by the atomic mass, and I can tell how many grams it will be produced. Okay, let's look at another example over here. What is the limiting reactant when 1.50 gram of lithium and 1.50 gram of nitrogen to combine? Okay, so what is given is, this part over here, it is 1.50 gram. This one over here, it is also 1.50 gram. Okay, when we look at this equation, is it balanced? Let's see. Lithium, it's not balanced. Over here, there are 3 lithium. Over here, 2 nitrogen, just 1. So let's balance it. I'm going to put a 2 here. So I have 2 nitrogen. So now the nitrogen is balanced. And now I'm going to put a 6 here. So lithium now is also balanced. Okay, so let's do the calculation here now. How many moles of lithium, if I have 1.5 grams, so it will be 1, so lithium, it will be 1.5 gram multiplied by, it must be gram, some grams per mole, okay? So lithium, when I look at the periodic table, I found that it is 6.94, 6.94 grams per mole. If I do that, I will have 1.5 divided by 6.94. I have 0.216 mole. Okay, so what about nitrogen? Nitrogen, 1.5 gram multiplied by, because it's a diatomic molecule, so I will have 14.01 times 2, that many grams per mole. Let's see what I have. It will be 1.5 divided by 2 times 14.01. That gives me 0.0535. 0.535. That many moles. Okay, so let's come back here. How many, let's see how many moles over here. For lithium, I have 0.216 mole. In order to match the lithium, how many moles of nitrogen should I need? Look at the ratio. In moles is 6 to 1, and therefore I need to divide it by 6. So that will be the number of moles of nitrogen is needed for 0.216 mole of lithium. Okay, so what would that be? It will be 0.216 divided by 6. I get 0.036 moles. That's what I need. What do I have now? I have 0.535. So I have more than what I need. That means this part, the nitrogen, we have excess amount. In other words, that means the lithium is the limiting reactant for now. Okay, so now we know this is a limiting reactant and we know that many moles. How about this one? Okay, lithium nitrite. Okay, so lithium nitrite, how many moles? If I have 6 to 2 ratio, that means whatever I have over here, it should be divided by 3. Okay, or you can say multiply by 2 and then divided by 6. So with lithium nitrite, I have 0.216 times 2 divided by 6. So that is equal to 0.216 divided by 3. I got 0.072. 0.072. So that many moles of lithium nitrite will be produced. That many moles. Okay. That's how we find out which one is the limiting reactant. And if you want to know how many grams of the product will be produced, what should we do? We use this number, the number of moles of the product, multiplied by the molecular weight of this compound. Okay, I think we did pretty well.